Hi everybody, thank you for joining us. Hopefully your reInvent is going great. Go ahead and put your headphones on now so that you can hear us, especially those folks in the back row. Can I get a thumbs up if you can hear me? Awesome. You want to test it?
Can you all hear me? Awesome.
Sorry about
awesome.
that. Oh, I'm sorry. That's a good thing, not a bad thing. Just to make sure you're in the right spot, this is DAT324. We're going to talk about deep diving into Amazon DocumentDB and its innovations. Everybody here, because it's a 300 level course, 324, we're gonna assume that you know what DocumentDB is. You've had your hands on with it. You're hopefully running a production workload on it. Who's running a production workload on DocumentDB? That is fantastic, perfect. So what's gonna happen is we're gonna skip the marketing page. You guys know the marketing material. We're gonna go basically straight into the architecture and why we built it, right? Because the magic with DocumentDB is really the architecture and all the components that make it up. Now, DocumentDB has been around since January of 2019. It's one of the fastest growing database services on AWS. Who has been using DocumentDB since, let's say, last reInvent, since 2023? Awesome. Who's been using it since 2022? A couple more. Who's been using it since 2019?
Wow.
My man, that is awesome. That's perfect. Before I was promoted to AWS employee, I was an AWS customer, and we were one of the first customers that started using DocumentDB. Me and you back there, we were like the first ones. I will tell you that since its release, its advancement, all the features that we've created have come from our customers. We've always worked back with our customers to build the features they want in an enterprise document database. Even though we've made some pretty substantial features and some pretty substantial releases in the past 5 years, I feel like this year, 2024, is probably our biggest year. So what we're gonna do is we're gonna start off going through what we've done this year. What are those big features in 2024 that we've focused on, that we've worked with customers on to release? Then we're gonna kind of go over a few of those features. We're gonna deep dive into a couple of them. We're gonna show you how you can navigate disaster recovery on DocumentDB. We're gonna talk about how these features can help you with cost and increase performance. And finally, we'll talk about some of the programmability features, some of the APIs that we've released. But I didn't introduce ourselves. Can't see us, that's us, just bigger, I guess. Really handsome man on there. I'm on there as well. My name is Cody Allen. I'm a specialist solution architect. I've been with this team for about 4 years. Like I said, I've been using it since it came out, but with me, he needs no introduction, but I'll let him introduce himself.
Thanks, Cody. My name is Vin. I'm one of the product managers leading DocumentDB, and I've been with the service for 3.5 years, and I'm based out of Seattle, and I'm super excited to be here today to share with you all what we've launched over the last year. Awesome,
thank you, Vin. So to start things off, we'll talk about the service. We'll look at the architecture. Now, if you've been using it for a while, this is familiar. You know what this is. The foundation of the service really is the separation of the compute on the top layer and that storage on the bottom layer. Because we have that distributed storage volume, that means that you don't have to rely on local storage to get that high availability and reliability. Now, traditional database engines, in order to have data durability, you have to write transactions on each instance. You have to write that transaction on each local storage of those instances. Now, with DocumentDB, the primary instance alone is going to send those write-ahead logs to storage. That means that you don't have that additional communication. Since that durability is handled on the storage layer, that means that you can have a DocumentDB cluster with a single instance and still have durability and high availability on your storage layer. You don't have to make that trade-off or that sacrifice to make that happen. Tasks related to replication, any kind of log processing, backups, all of that is handed off to that storage layer. Additionally, one thing that a lot of folks don't realize is that each replica in your instance handles its own buffer cache. We do not dirty the buffer cache between instances. So what that means is let's say I update a document. When I update that document, that goes to the primary sends it to the distributed storage layer. The primary is then gonna send a write-ahead log to the secondary and say, hey, we just updated this document, make sure you update it. Secondary looks at it and says, okay, if I have it, I'm gonna update my cache. If I don't, cool, you made your update. I don't care, I don't need it. So we keep those caches independent from each other. Now, because I want to make sure that we cover what's new and go over all these features, we're going to talk a little bit more about that compute layer, the backup layer a little bit later. But the point is, everything that we've done with DocumentDB is purpose-built for the cloud to help enterprise customers run their document database workloads. We have a lot of customers. We have digital native customers like Rappi. We have large enterprise customers like Capital One. We have customers that cover gaming, financial industry. Amazon.com, fulfillment by Amazon and Amazon.com. That is running on DocumentDB. So we have a broad range of customers. I would encourage you to go check out that customers page if you've never seen it before. We have some really good customer references, some new ones that we've added this year that kind of dive a little bit deeper into those. But with that said, let's move on to the fun stuff, and Vin's gonna walk us through all of our new innovations for 2024.
Thanks, Cody.
Yeah.
Awesome. So thanks for that quick refresher. Awesome introduction there. So it's always really good to hear from our customers and their use case with DocumentDB. But one thing that's really important to us as a service team is we actually get to work with you and get your feedback. And that's actually what's really centered around a lot of the innovation that we launched this year. So a lot of the features that we launched this year was actually in partnership with our customers. Now, I would recommend taking a picture of this slide because we're not going to have the time to go through every single feature here. It's going to take quite a bit of time. However, if you just take a search on any of these features later on, and after the session, of course, not right now, you can find more details through our documentation on each one of these features. Now, going top down, you'll see that we've made investments across performance and scale with features such as document compression and increasing our connection limits, to cost optimization with IO optimized, which is going to provide you predictable IO pricing. We've also launched features around AI ML and high availability with global clusters, managed switchover and managed failover. Now, so for the remainder of the session, what we're going to do is really dive deep into several of these, the ones with the stars, and dive deep into those features to tell you how it works, how you can implement it in your environment. So the first feature I want to talk about is IAM authentication. And this is a feature that many of our customers have been asking for a while, because what we're starting to see is a lot of our customers centralize their authentication mechanisms across their AWS resources, which include DocumentDB. So with IAM authentication, what you would do is, with your clients, you would reach out to AWS IAM, specifically the security token service, to get a token. Then the clients would then use that token to authenticate against DocumentDB. Now, one thing to note here is that the identities are created within your DocumentDB cluster, and they are managed within the external database. So this is something that you have to configure before you use IAM, or else your DocumentDB cluster won't know what to do with those tokens. And we have step-by-step instructions on how you can achieve this through our docs as well. You could also use IAM authentication on top of existing RBAC roles and users in your DocumentDB cluster. So for example, let's say you have user 1 has access to database 1 and database 2. Your IAM entities could be mapped on top of that, so that when they're logging in with IAM, they could also have access to database 1 and database 2. Now, as an admin, you will also have the ability to monitor your IAM authentication requests through CloudWatch. And this is really important for anyone who's using IAM, is that you could have full control and visibility over your IAM requests. Okay, the second slide I have here is vector search. This is a big area. This year we did launch HNSW. Now I'm not going to go into the use cases here, because we did have a session this morning, DAT324 supercharging app intelligence using Gen AI. If you missed that session, however, do take a picture of this. All our breakouts are recorded, and you will have access to this after reInvent. But just as a quick show of hands, who attended that session this morning? Okay, so a few of you. You'll notice that Cody was the presenter there. But this is going to be an area that we're going to continue to invest in 2025 and beyond. All right, so with that said, let's go into our next set of features with global cluster improvements, specifically managed failover and managed switchover. Now, if you're not familiar with global clusters, just a really quick refresher, because we're going to reference it a lot. Global clusters provides you the ability to provide your cluster to be spanned across multiple AWS regions. And this is going to provide you two benefits. One of them is disaster recovery. Because you have a copy of your data in another region, in the event of a disaster, what you could do is fail over to that secondary region. And secondary is data locality. Because you have a copy of the data in another region, you can query that data for very low read latency. So the two primary benefits. So how would you go about setting up a global cluster? Let's say I have a cluster, a DocumentDB cluster in North Virginia, US East 1, and I have my application connected to it. What I would then do is go to the AWS console or CLI, and I would just simply add another region. Very easy, pretty much one click. But notice that the replication service is replicating data from the storage tier. And this provides you actually a really good advantage, because instead of having the instances do that compute of data replication and moving data between the two instances, this is happening on that storage tier. So it frees up your application to use the database in its full. You can also connect to that secondary instance, as I was mentioning earlier, from your second application. Now, I also like to point to you that here you see there's about 3 instances per cluster, but it doesn't have to be that way. In fact, what you could have is more or less instances, larger or smaller instances, depending on your business need. So you could have 1 instance, for example. You could have a smaller instance, for example. In fact, you can even have 0 instances. And what we call this a headless secondary. Now, in fact, what this will enable you to do is pretty much save on a little bit of cost. But I do want to caution you that if you're trying to have this set up for a failover type of scenario, you will have to spin up an instance beforehand. And that takes about 7 to 10 minutes. So that's going to contribute to your overall failover process if you do not have an instance in your secondary region. All right, let's go into one of the 2 new features that we have, which is managed failover. And the benefit of managed failover is the primary objective of this feature is to allow you to promote a secondary to primary with no data loss. And that no data loss is going to be one of the key differences between managed switchover and managed failover. So, you would want to use managed switchover for controlled scenarios. And I'll talk about why controlled scenarios in a bit. First of all, you could use it for maintenance. For example, let's say you want to perform maintenance in a single region. You could first switch over with no data loss, perform the maintenance, and switch back. You could also do things like multi-region follow the sun applications. Let's say you have an application across multiple time zones, across multiple regions, and you want low latency writes. You could use switchover for that type of use case. And last but not least, a very common scenario of switchover is to pair it up with managed failover. You could also use it as a 0 data loss method to fail back after a failover. However, one of the things that I like to call out is that switching over can take several minutes, and I'll explain to you why right about now. So here I have my 2 clusters set up for my global cluster. What happens when I hit switch over? The moment I hit switch over, the first thing that's going to do is the writes on your global cluster are going to be disabled. And the reason why we do this is that this allows our clusters from primary region to be seeded over to our secondary regions. Now, once all the data has caught up, what we will then do is proceed with that promotion process. So you can see here that I'm going to promote that US West 2, which is in Oregon, to the primary, and then I can continue to perform writes against that new region. All right, our second feature is managed failover. And the primary objective of this is to promote a secondary to a primary, very similar, but the main objective here is to minimize cluster downtime. So you really want to use this for business continuity events, in an event, for example, where there's a complete service outage or there's something really went wrong in that region. And one thing I like to call out with both switchover and failover is that the topology is maintained. And what I mean by that is, say something were to go wrong with your cluster. When that cluster comes back online, the DocumentDB service will automatically add that back into the global cluster and do that seeding for you so that you do not have to do that manual post cleanup of any sorts. So let's take a look at how this works. Let's say I have my setup between North Virginia and Oregon, and something were to go wrong. Very super rare case of something going wrong in North Virginia, and the cluster is down. I'm going to hit failover, and the moment I do this is that I'm going to be able to promote that secondary region to primary. One thing to note here is that the data that is being seeded over, if you have any ongoing transactions, it may be lost. However, remember, the objective of failover is to minimize downtime and to maximize the uptime of the overall global cluster. So let's say sometime later, US East 1 comes back online. However, the cluster may not be in a healthy state. We don't know the state of that data. So what we are going to do is seed the data over from primary to our secondary cluster. It's going to be, and also application 1 can connect to that cluster in Oregon while the seeding is in process. And then once that cluster has fully seeded, the endpoints will be open and you can connect to it. All right, so with both switchover and failover, one thing I like to call out is that while we make it really easy to failover or switch over, there are different cluster endpoints that your application may need to connect to. So let's say you have a application and you are failing over switchover. One thing that you may have to go do is change that application connection string. However, a very common workaround is to actually introduce a Route 53 hosted zone. And this is actually going to be a method for you that actually helps you, instead of having to make an application change or application change, you can actually just use your application and point it at, say, app global, my domain instead. So here's an example. Let's say I have app 1, and the point of app 1 is to do both reads and writes. And my primary is currently in Oregon. So the entry in my Route 53 is going to redirect all the traffic to Oregon cluster. And if I do a switchover or failover, all I have to do is update that entry instead of making an application change. So I could just point my application traffic pointing to this secondary region. All right, let's get into a demo here. I want to actually show you how easy it is to actually initiate a managed failover. But before I do that, I want to just show you my setup. For my setup, I have a cluster that's in US and I have a cluster that is in Ireland, and both of this is part of the global cluster. I also have an application, and this application is simply just going to insert writes every single second. So you can think of this as a heartbeat. I also have a monitoring application that's going to monitor my global cluster as well as the application as well. And this is going to tell me things like who is currently the primary, where's the application that's doing the writes originating from. Then I'm going to initiate a failover. And what this is going to do is have the application, I'm also going to fail over the application, by the way. And the application is going to do exactly the same thing in Ireland. This is going to insert every single second, acting as a heartbeat. So at any given point, if I see in our demo where docs are not being inserted every single second, you could think of that as the overall downtime. All right, with that said, let's go ahead and go to our demo. So here I am in the AWS console, and I have a cluster called Demo Cluster. This spans across 2 regions. My USA East 1 cluster is currently my primary cluster, and my Ireland cluster is currently in EU West 1, serving as my secondary cluster. And so, all right, so let's go over to our monitoring application, and I'm going to show you what our monitoring application is going to do. So there's a few elements on this page, but I want to point your attention to that graph. So that graph is actually showing the number of documents being inserted over time. And you can see that it is inserting every single second. You could think of this as the heartbeat of our application. And on the right side, I have a map with an icon of a database, DocumentDB, and is currently in the US, hovering over North Virginia. That's the location of the primary. So later when I do a failover, that icon should go over to Ireland on the top right. I also have the current time, the most recent inserted document. Notice how it's approximately about 1 to 2 seconds behind. As the page refreshes, what we're going to see is this being updated. I also have a application location where the application is issuing the writes, and I have the primary DocumentDB server URL. Here you can see that it does state US East 1 in the URL. All right, so I'm going to go back to the AWS console, and let's go ahead and initiate that failover. So here I'm in the console. In order to failover, I'm just going to select that demo cluster, which is already selected. Then I'm going to go under Actions and click on Switchover or Failover. And upon switching that, I'm going to have the option to either initiate a switchover or initiate a failover. I'm going to select Failover. And one thing I like to note that, remember, the main goal of failover is to maximize the uptime of my global cluster. So there is the possibility of data loss. Any ongoing transactions may be lost. I'm going to select my primary cluster as Ireland cluster. And then I want to just click on confirm to confirm that I want to allow for data loss in case there is an event of any ongoing transactions. Okay, so you can see in the banner very top, it says switching over Ireland cluster as the primary of my global cluster. And you can look under the status of failing over as well. All right, I really want to go back to the monitoring application to show you this in action. So, all right, so notice how there's a little blip over there. What that indicates is that writes actually were not able to make it to the database at the point in time. And it's approximately 2 bars, which means that our failover, the overall downtime was approximately just 2 seconds. So I was able to fail over from US to Ireland across the ocean there with just pretty much 2 seconds of downtime. You can see the icon is hovering over Ireland. You can also look at the application location, which is currently in EUS1, and the URL is also EUS1, which indicates that the main primary is in Ireland. Okay, let's go back to the console. I just want to show you one more thing really quick about the status of the cluster. The 2 clusters are in the global cluster. So you can see here that it's still failing over. I'm just going to click on refresh on the AWS console page. And this should refresh the status. You notice that here, the Ireland cluster is currently now the primary cluster, and the USA East 1 cluster is in a resyncing state. That is, the data is now being propagated back. So in about a few minutes over time, this will be all available after it's fully finished syncing. Okay, a few key takeaways. I'm not going to go over all these key takeaways, but feel free to take a picture of this. This is really just talking points and notes for you to bring back to your organization. If you're thinking about implementing global clusters back in your organization, just a few tips and things to really consider if you're considering global clusters. We also have a lot of this information in our documentation as well. With that said, I want to pass it over to Cody, who's going to deep dive into performance and cost to share a lot more over there.
Man, I thought I had something big to live up to. Everybody was clapping for you in the other session. That was incredible, Vin. Thank you. Yeah, so let's switch gears. Let's talk about cost and performance a little bit. Now, the great thing about JSON and the document data model is, well, it's flexible, right? Traditionally, what we do when we create a new application, a new workload with a relational database is we start with a relational database, right? We define the tables, we define the keys, primary key and the foreign key. We create our pure join tables, right? We have to build this relationship and the structure of these rigid relational database tables before we even touch the application. And then we start touching the application, we realize that we need to change things. Well, we have to go back to the database and do it first. Document database model, JSON model allows us to change that around, right? We now start with the application. The application is defining the database structure. It's defining what our collections, our namespaces look like. Our end user experience is the goal here. We want to improve that, and we can do that by starting with the application. Now, as your application grows, right, as you have more users, as you start to evolve, you're going to find that, well, you need new fields. You have new fields that you want to capture. Strings are going to become arrays. Those are going to turn into embedded documents. The entire structure of your data is going to change. It's going to grow as you evolve. What you're going to find is as you move from development to production and later releases, is that a different document model is going to be more performant. You're going to add more features to your application. Your user experience is going to improve. You're going to get better queries, better results. And obviously, as you add more fields, well, your document size is going to grow. And beyond that, beyond your document size growing, as you onboard new users, more people download your app, you do merger and acquisitions with other companies, you bring on legacy data sets, well, you're going to get a lot more documents. It's going to continue to grow. Now, we talked about the storage layer earlier with DocumentDB, but the entire service was designed to help you scale as needed. The storage layer takes care of that. The compute layer, well, you can increase the instance size. You can add more instances as your workload grows. And since you get native integration with CloudWatch, you can even set up orchestration with CloudWatch alarms, Lambda, EventBridge to automatically scale that up and scale that down. If you notice, it's heterogeneous size. You don't have to have instances that are all exactly the same size. You can have readers that are larger than your primary. You can have a primary that's larger than your readers. There's reasons why you would and wouldn't do that, but that's for a different conversation. That distributed storage layer, that's going to grow for you. It grows in 10 gigabyte chunks as your storage grows. And when you do things like drop namespaces or drop collections, drop databases, it's actually going to shrink for you as well. Now, this is fantastic, right? The ability to grow and scale is fantastic, but we also want to be good stewards of our environment, right? The capability to scale is wonderful, but we need to be efficient, right? We need to worry about cost. We need to worry about our performance. Now, there are design implementations that you can do that will help out. So things like reducing your key size. This is a big one. JSON's great because it's human readable. It's easy for us to parse, but it doesn't need to be, right? We don't need to read it. Our applications just need to read it. Every character that we use in a document is space used on disk and space used in the indexes as well, and that can affect your working set, right? That can affect your cache. So for example, let's take this document that we saw earlier, and we're gonna change it from this over to this, right? Pretty simple changes there. We just saved 67 bytes by doing that. Our data stayed the same, we just changed our key names. We moved from about 457 bytes down to about 385, saving us about 15% of savings on that one document. We're talking about bytes here. Now, doesn't seem like much, but this can become very significant as your data layer or as your documents grow. When you start scaling up to 5 billion documents, for example, this can equate to a saving of over 300 gigabytes. As you scale up to maybe over 20 billion documents, you're talking about over a terabyte of savings. This is something that we see pretty common. This is something that we see pretty often with customers, is a majority of their document size is made up of that key, not of the field itself, but of the key. And this is wasted space, right? You don't need that. We have customers that will move to this and even create an abstraction layer at the application layer that will define that will convert that for you. But this is massive, taking care of that savings. If you joined us for our DAT324 session earlier or yesterday, we talked about this a little bit. But we added another feature in 2023 that helps you out with this beyond making these document changes. This guy, he's pretty important around here. He's the CEO of Amazon. He used to be the CEO of AWS. And when he was the CEO of AWS, he had a saying that there is no compression algorithm for experience. Now, what you might not know is he got cut off. His mic got shut off before he could finish. The full quote was, there is no compression algorithm for DocumentDB. But guess what? We changed that. There is compression for DocumentDB now. To understand compression on DocumentDB, let's talk about how data is stored. Now, we use 8 kilobyte pages to store your documents. In an ideal situation, let's say that you have 2 4 kilobyte documents, that means that they're gonna fit nicely into a single page. If your application only needs one of those documents, or if it needs 2 and those documents are on the same page, that means we have 1 IO. We only have to do a single IO to get 2 documents. But what happens if your document is greater than 4 kilobytes? Let's say it's a little bit bigger, let's say it's 5 kilobytes. Now, DocumentDB is going to store that 5 kilobyte document in that page, but we have this unused space, right? We can't use it for anything else, so essentially it's wasted. That means that if I need to get 2 documents from DocumentDB, I am guaranteed to do at least 2 IO. And there's cost for that, right? We have to pay for the performance. If I have to go reach back to disk to pull that back, that's additional IO. That's additional network traffic I have to do, and I pay for IO. So there's a cost both in performance and billing. And again, we go really deep into this in our session DAT317. We're having a repeat on Thursday, shameless plug. Come see us if you haven't seen it. We'll talk about how pages are stored and how compression can help. But you can imagine how this affects really, really large workloads, or let's say that you had documents that were 7 megabytes in size, right? We have a document size limit of 16 megabytes on DocumentDB as the JSON file size limit. But even if you had documents that were 7 megabytes, that means that for a single document, if it was perfectly fit into an 8 kilobyte pages, you're gonna need 875 pages just for one 7 megabyte document. And that's where compression came in. We introduced compression in 2023 to help out with this. So in that case where you have a 7 megabyte document, if you had a 2-to-1 compression ratio, guess what? You cut your IO by 50% just by enabling that. Now, this is all straightforward so far. Compression is good, and big things compress better than small things. but we're trying to squeeze the most performance and get the best cost out of DocumentDB as possible. Now, when we released document compression in 2023, the default compression size was 2 kilobytes. So that means that if you had a document that was over 2 kilobytes, good, it compressed for you. But if it was under, if it was 1.5, or even if it was 1.9999 kilobytes, it didn't compress. That you had to be at least at that 2 kilobyte level. But now what we've introduced with compression this year is the ability to set the compression threshold. You can set it as low as 128 bytes, or you can set it as high as 8 kilobytes. So that means that if I have a 1.5 kilobyte document and it compresses 3-to-1, I get it down to 500 bytes, that means that instead of fitting 5 of those into a page, I can now fit 16 of those into a page. That means that I have less I/O. So if you consider I have 1,000 documents to get, instead of doing 200 I/O when the documents were larger, now I'm doing 63. And again, that's lower cost, less I/O threads. And less I/O threads means lower CPU usage on your DocumentDB instance. So you're gonna see a performance increase on this as well. To give you an idea of what this looks like, we ran a couple tests. In this first test, this was rate limited. So what we did is we ran some workloads with 5 kilobyte documents and 1.5 kilobyte documents. We ran them compressed and uncompressed. Now this first one, we set the amount of inserts per second it can do. We made all the workloads run the exact same amount of inserts per second, and we ran them for a capped period of time. So essentially this means that all these workloads are inserting the same amount of documents. What we can see here is that a huge drop in I/O by doing this. We have a 30% drop in I/O on those large documents, but we still have an 11% performance increase or drop in I/O on those smaller documents, 1.5 kilobytes. And we also see that performance increase. We see that CPU usage go down. A lot of a misconception that we have is enabling compression will negatively affect CPU, right? Because my compute layer has to do the compression of the documents and has to decompress them. But what you actually see with these rate limited workloads is that CPU goes down. The reason for that is that drop in write IOPS. Drop in write IOPS means we have to dedicate less CPU threads to do those IO operations. But there's a trade-off here, right? This is great, but the other side of this is, well, our second test. And with this one, we essentially cranked these up to 11, right? This is your Cyber Monday deal. This is your surprise sneaker drop for Nike. This is basically throwing as much workload at this DocumentDB instance as its network could handle. Obviously, I/O goes up. I/O goes up, that means that we can handle more transactions. We have more inserts per second that are happening. But the other side of this is higher CPU usage. And the higher CPU usage is happening because you have more I/O threads. You have more I/O threads that are handling all that. Now, this is the anomaly. This is the outlier. Most workloads rarely ever see this or they don't see it, but just understand that compressing is good for your normal day-to-day workload, but if you do have those spike events, you could see an increase on that CPU usage on those instances. Now, switching it over, let's talk a little bit about programmability. To recap, what we talked about so far is, well, JSON's great because we can evolve our application. We can change our schema simply by declaring it. And compression is great because we can optimize that potential growth and use less space. But sometimes we need more than this. You know, sometimes applications shouldn't just have a free-for-all to change things in the schemaless design whenever they want, right? We need to have some controls on this, especially in the financial industry. You need guardrails. You need to protect your data. You want to allow new data types, but you still want to maintain integrity and security. Account numbers need to be exactly 10 digits. Transactions cannot be 0 or negative amounts. Because of regulation requirements, certain fields are required to be in your documents. There's also a need to prevent errors, catching data issues before they enter your collection. And this is what customers shared with us when we introduced the JSON schema validation in DocumentDB. This lets you set up rules that you have to follow, you have to abide by whenever those transactions go into DocumentDB. Now, most workloads are performing that validation not just at the database layer, but at the application layer. So for example, at the API layer. The API layer, you're making sure that your URI parameters are there, your query strings and your headers are present or properly formatted. You're making sure that your payload matches the JSON request method. You're putting all of these controls in it at both layers. Best practice, though, is to do this at both layers, both at the application layer and at the database layer. From the API layer, you're able to catch these errors before they hit the database, which means less wasted resources at the database layer. That means that you can provide custom and immediate feedback and error handling to your customer. Now, at the database layer, well, you're ensuring that data integrity, right? You're protecting the data regardless of where it's coming from. You're protecting against direct database access if anybody's doing Mongo shell commands, and you're ensuring consistency across multiple applications that might all be touching that at once. Now, this is fantastic, but customers shared with us that this actually can cause speed bumps. This can cause hiccups in their development process. They're constrained by these validation rules as they're trying to develop new features, right? It's preventing them from having an environment in development that's the same as production because they want to add more fields. They don't want to be constrained by that. So what we did to address this is we introduced that bypass document validation parameter for JSON schema validation. This allows you to skip those validation rules whenever you're inserting or updating documents into a collection that has those validation rules defined. For example, in events where you want to migrate a large amount of legacy data, which is what we're doing here, you can utilize that parameter to temporarily allow you to bypass that. As you start working with customers to develop new features, you want to change your schema. This makes that development process go a whole lot quicker. Or let's say that you have an emergency fix that you have to push through, this new parameter allows you to bypass that. Now, 2024 has been a very, very busy year for us. Again, this is not the full list of features that we've come out with. These are just the ones that we wanted to highlight. We have a few features on the roadmap, by the way, that unfortunately we're not able to make this list. We wanted to, but they're close. I might get in trouble with Vin for saying that, but just a hint. There's some big things coming very, very soon for DocumentDB. But everything that we've gone over today is possible because of you, because of our customers. Me as a solution architect, I sit down with you and I figure out how you're using it, what you need, what are those features that are important to you. Then he sits down with our customers to figure out how we can work with our engineers to release these features, to give you these extra capabilities. As we go into 2025, we're gonna keep this pace of innovation going. I think we're gonna see even more releases in 2025. As a matter of fact, I know we are. We're gonna see more releases in 2025 than we saw in 2024. But as we do that, we want to continue working with you. We want to continue building with you. We want to continue making these features that you led. The JSON schema validation is a great example of that. Because of our close partnership with a customer on that JSON schema validation, we were able to streamline that release and custom build it exactly how they needed to. I think the production time was cut down by months by working with the customer on that. But with that said, we look forward to hearing from you. What are your use cases? What are those features that you want? What are those features that can help you innovate, save costs, and increase your overall performance and workloads with DocumentDB? Some things to check out, take a picture or scan these. We have our DocumentDB deployment scanner. This is a way to look at your clusters and see if there's any optimization that you can implement fairly easily. We have our compression reviewer. So if you have a DocumentDB cluster that does not have compression enabled, you want to have an idea of will compression make a difference? Run that tool. And these are simple Python scripts. I think they're like 100, 200 line Python scripts, very, very basic, very simple to run. Check them out and leave us feedback. Like if there's anything you want to see in those scripts, let us know. We did release a brand new data modeling ebook that's very specific, extremely specific to DocumentDB, that tells you how you can do data modeling and advanced tips for those optimizations that are specific to DocumentDB. And we've partnered with the training and certification team to create a course, a entire course guideline for DocumentDB. It'll take you from an introduction all the way up to cost and performance tuning, data modeling, and really let you interact with that. But with that being said, thank you so much for joining us. Please enjoy the rest of your reInvent. DAT324 on Thursday, an extreme deep dive into pages and DocumentDB. And please remember to fill out that session. Thank you, everybody. Appreciate it.